Hello dear students, today in this video we are going to study hexadecimal number system. In our last videos we have learned about octal number system, binary number system. Now we know that whenever we start with any number system, the first thing which we see is base of the number system. The base of the hexadecimal number system is 16. Its name itself represents hex plus decimal, 6 plus 10. So 16 is the base. Base is nothing but number of symbols a particular number system uses, that is known as base. In hexadecimal number systems, the symbols used are from 0 to 9, that is 10 symbols, 10 numbers, and A to F. These alphabets are used in the hexadecimal number systems. Total, if we count, that becomes 16. Okay, now again, what is the need of hexadecimal number system? We know that the binary string or binary numbers, if the number is large, so binary string becomes longer, and that longer string is difficult to manage. Okay, so it is not human friendly. So a hexadecimal number can reduce the binary string, and we can have the compact numbers if we use hexadecimal number system. Rather, if we compare hexadecimal number system with the octal number system, hexadecimal number system gives us more compact nature. Okay, so and that's why in microprocessors and in microcontrollers we use hexadecimal number system. For the memory address representation also hexadecimal number system is mainly used. Okay, so this is all about the need of hexadecimal number system. Now we'll study the conversion of hexadecimal number system with binary number system. Now before starting the conversion, we should know, we'll see one chart like decimal number, then hex number. For example, decimal number 0 to 9, we have the same hex equivalent for that. 0 hex number is 0 to 9, the same hex equivalent for decimal number. Now for 10, I can represent hexadecimal number as A. For 11 can be represented as B, 12 C, 13 D, 14 E, and 15 is F. Okay, now if I A, B, C, this is the hex number. Okay, so if I want to convert this hex number, I can represent the hex number like this, or other way is A, B, C. This way also we can represent any hex number. Okay, so if I want to convert this hex number into binary, the steps are very simple. You write every hex number separately, and we have to write every digit, every bit, or every number of hexadecimal number system in 4 bits. Why 4 bits? Because we know that hex number systems base is 16, binary number systems base is 2. I can represent the hex number system in terms of binary like 2 raised to 4. Okay, so that's why 4 bits are sufficient to represent any hex number. Okay, to represent hex number in binary. Okay, so C can be represented as, C is nothing but 12. C is nothing but 12. So firstly we'll write the decimal equivalent of this. B is nothing but 11. A is 10. Now 12, how can we represent 12 in binary? We have seen this in our earlier video. If I want to represent 12 in binary, what we do is we keep on dividing the number by 2. Double method, right? So here we write the quotient, here we write the remainder. So 2 6 are 12, remainder 0, 2 3 are 6, remainder 0, 2 1s are 2, remainder 1. 1 cannot be divided by 2, so I will shift it here, then I will go bottom to top. So 1 1 0 0 is the binary equivalent. Okay, so C can be represented like this. B is 11. So how can I represent B? So B, for B, the same method. So 2 5s are 10, remainder 1, 2 3s are 2 2s are 4, remainder 1, 2 1s are 2, remainder 0, and 1 shift here. So 1 0 1 1, 1 0 1 1. This is binary equivalent for this 11. 10, the same way if I do, I'll get 1 0 1 0. With practice you can do that. So this is the binary equivalent for this hex number. Okay, so any number, for example, simple number, if I take 3a, this number is in hex. If I want to convert that number in binary, take every digit separately. Okay, a is nothing but 10, 3 is 3 only. So 10 I can represent 1 0 1 0, and 3 I can represent 0 0 1 1. So this is binary equivalent for this hex number. So in hex number, while converting it into binary, we have to take help of 4 bits. Okay, 3 can be written as 1 1 only, but we have to take help of 4 bits. Okay, and that's why we are adding 0 0, right? So this is all about converting any hex number into binary. Now if I want to convert any binary number into hex, the process is again, the steps are again very simple. For example, take any binary string 101101. Okay, this is binary. If I want to convert it into hex, so what I will do is write the string as it is first. Okay, then starting from right. Okay, 1011, this way 1011. Part that string, divide that string in 4 bits, 0 1 0, only 3 bits are there, so add 0 here. Okay, so 1101, what is that? It is equivalent to 13. By practice you can do that. Okay, and then this is equivalent to 12. How can we represent 13 in hex? 10 is A, 11 is B, 12 is C, and 13 is D. I can write D. 12 is C, so I can write C. So CD is the hexadecimal equivalent for this binary string. Okay, now how we got this 13 for 1101? So for that you can refer the first the binary to decimal and decimal to binary conversion, that for video you'll get to know how we'll get 13, or by practice you can learn this easily. Okay, another example, I'll take another binary number 10110. Okay, so what I will do is I will write the string as it is, then 1101, have the group part that string into 4 bits group 1101. So this one is single now, so you need to add 3 zeros, so in order to make it group of 4 bits. So what is that? 1011, again it is, I can do like this, what, 1 2 4 8, so 8 2 10 and 11, 8 4 2 1, so 1 to 8 9 10 11, same we are getting, and this 1. So 11 is nothing but B, 11 is nothing but B, and this one. So this is hex equivalent for this binary code. Okay, so this way we can convert any binary number into hex or hex number into binary.